So now we are at a unit vector. So we talked about magnitude and a vector u for which the magnitude, so remember that this notation here means magnitude, equals 1 is called a unit vector. And so we want a unit vector because it will be a distance of 1 and it will go in the same direction as the given vector. And this will be useful again in later mathematics courses. Right now, I'm just going to teach you the formula. And so we want to figure out if this is a unit vector. So let's go ahead and find the magnitude. Now, excuse me, if you want, you can create a diagram if you'd like, or we know, and you know, it's Pythagorean theorem. Hopefully we're feeling okay since we've been doing this for a long time. It's just the square root of -5 squared plus 12 squared. Well, if I go ahead and find this, I get 25 plus 144. And I could even go further. Let's go ahead and just go further. But hopefully we're seeing there's no way this is going to be a value of 1. Well, the square root of 169 is 13. So what this is telling me is this is not a unit vector. Okay, so there is a way where we could find a unit vector, and that is given in this formula here. So what you do is you take your vector and you divide it by the magnitude, which hopefully would make sense to you. So that means that this will go in the same direction, but now we are dividing by the magnitude, so that will force it to have a magnitude of 1, right? Because something divided by itself is always 1. So if we want to find a unit vector in the same direction as this given vector v, which is 3i minus 4j, what I'm going to do is I'm going to put my vector, we're going to just call it vector u, and we're just going to put it in component form. So this is 3, -4. Well, we need to divide by the magnitude. So I'm just going to put it like this. Well, then that means we have to find the magnitude. So once again, it's the square root, 3 squared plus -4 squared. I'm going to get 9 plus 16. So that's 25. The square root of that is 5. So we will replace our magnitude with 5. So what we get here, we get this unit vector. It's going to just be a fraction. It's 3/5. And then we go down -4/5. Since, again, with mathematics, however the problem is given to you, that's how you should give the answer. So I should go one step further and just say, this is 3/5 I minus 4/5 j. So what you found, and again, this will be useful in another course, but what you found is, let me give myself another color. You have this vector 3i, and I'm going to put it in standard position, so it will start at the origin. 3i minus 4j, so, you know, something like this, right? Well, what we found is this vector will just be here, going the same direction, but it will be 1 unit long. All right, the next topic is putting vectors in trig form. And so this is going to really help us with applications, which will be our last video. So this trig form is given to you, all right? It gives us a lot more information than just component form, right? Or in terms of I and j, because what I can see in trig form, which is really nice, is I can clearly see the magnitude, and I'll clearly be able to see the direction. So for example 5, we're given the magnitude and the direction. So this is pretty straightforward, which is nice. So my vector V in trig form would just be 8 parenthesis cosine of 45 degrees I plus sine of 45 degrees J. And that is all you have to do. Say you wanted to take it a step further. Oh, forgive me, that is not true because it says we want it in this form, so we are not done. So now we can actually evaluate this. So then we can put it in terms of I and J without it being in trig form. Well, cosine of 45, we know what that is. That's root 2 over 2 I. And we know what sine is, which is root 2 over 2 J. If I distribute that 8, those 2's will reduce out. And so I end up getting 4 root 2 I plus 4 root 2 J. So what we found here, again, if you're a visual person, we have this vector. I'm going to put it in standard position, just approximate. It looks something like that. Well, that's that vector where our horizontal movement is 4 root 2, and then our vertical movement is 4 root 2. And we come up with that vector. But what this thing is telling me is that this has a length of 8 and that our direction is 45 degrees. So trig form is a little bit more useful because it gives us more information. Well, now let's work in the opposite way. Now I'm going to give it in terms of I and J, and I want to come up with the trig form. So I'm going to go ahead and I have I minus root 3J. So let me just, if I have I, again, it looks something like this. I'm approximating. All right, so let's go to create a triangle. This would be 1, and then we went down negative root 3. Well, in trig form, the first thing we need is that magnitude. So let's go ahead and find our magnitude. And again, I name this vector V. So it's going to be the square root of 1 squared plus negative root 3 squared. That becomes 1 plus 3. So that's 4. Take the square root of that, we get 2. So what we found is we know the length of that vector is 2 units. Well, now it's so nice because it's so similar to previous lessons. Now we got to find that direction. Well, just like previous lessons, I'm going to use inverse tangent. I could use cosine or inverse sine, but in case I got that too wrong. So inverse tangent of opposite over adjacent. Now that is on your unit circle, okay? If you go to your calculator, it's going to, remember inverse tangent is only defined from here to here. But, we're just using inverse tangent to help us get there. We have to actually, based on our instructions, we have to give the direction this way. I'll make it better so it stands out. This is the direction we have to give. So looking at our unit circle, that would end up being, I believe, I wish you were talking to me so you could help me. I'm using my brain here. So it would be, let's see, 5 pi over 3. So if I put this, well, and it wants actually in degrees. So let me just put that into degrees. that will end up being 300 degrees. So make sure you're just paying attention, because it's just, excuse me, I'm so sorry. Because these could change on you. It could want it in radians, it could want it in a decimal if it was on the unit circle. So just pay attention to instructions. So this in trig form is 2 parentheses cosine 300 degrees I plus sine of 300 degrees J. And in the next video, we'll really use this for our applications.